Hey guys, I'm Jose and this is the second tutorial of the second season of this processing series. So today we're going to see how to do an L system, or at least my own version of it. So let's get started, right? So we're going to start with a very simple setup as usual. And as usual, we're going to start from scratch. And we are basically going to do 3D setup, right? So you could work in P3D or in just OpenGL if you want. And I'm going to work with Toxi clips for the vector math. And in this case, I'm going to work also with import PCCam, right? So I'm going to just say background so smooth and the background black, right? Could be white, just doesn't matter, right? So it's always good practice to check what we're creating. Maybe this should be slightly smaller, right? So let's go ahead and just use PCCam. And cam equals new. If you're not familiar with some of the stuff that I'm showing here, please refer to the first series of tutorials where we showed how to work in 3D. Because this has been covered already, I'm not going to spend too much time explaining what we have here. I'm just going to make a very simple setup with a box with no fill, so we can understand 3D space and how PCCam allows us to operate, to move around in this environment, right? So very simple. We can navigate with the mouse and work in 3D space, right? I'm also going to add a stroke weight of 1. Right, so the next step will be create a new class. In this case, we're going to try to keep it super simple, right? We're going to try to just make one stick, and this is the name of the class that we're going to create, a stick, right? Of a point, basically, that will just, every time it gets created, it will just move from the location in which it's created to a new position, right? And that's the only thing that it will do. And basically, that class will call itself over and over again recursively, so it will be like a recursive class, and with that we will create something like an L system, right? So let's do a new tab called stick, so we can do a class called stick, right? Stick, so that's the class. We're going to say a vector 3D of location. That will be one of the main variables. Very simple, right? So we're creating one main variable being the location, and we're going to do void run. This will be the function that will call all the other functions, like void display, that doesn't exist yet, and we're going to create it by saying void display location.x, location.y, location.z. And this point will be yellow, and we'll have a thickness of 4, right? So this stick, the only function it has is just the display that will show the vector in which we created. So we need to provide a vector in order to create one of these guys, and once we create it, it will just show itself as a point, right? So we can go ahead and save this script, somewhere in the desktop, and we're going to call this L system. Right? So if you don't know what an L system is, it's something that resembles a tree, like a branching structure. So we're going to see how to create something like that. It would be good to just research a little bit on L systems to just know who was Mr. Lindermeyer, that I think it was the creator of them, and how the structure. We're not following exactly the rules that Lindermeyer used for his L systems. We're basically creating a recursive class. That is what I'm interested in showing here. The idea of doing a class that is very simple, but it's kind of an object-oriented version of an L system. So how do we bring this class into the canvas now? We could say something like stick. We can call Bob, right? Doesn't matter. So Bob, it's a new stick, right? And we need to provide a vector here. So I'm going to say v, right? And the vector v, it's a new vec3d, basically 0, 0, 0, right? So we're creating a new instance of this class stick, basically in the center of the screen, and now we need to just say Bob.run. We can give any name to the instance of the class, right? In this case I'm saying Bob just to make explicit that this could be any name, right? So you see that we have a point in the center, right? That's pretty good. And let's do a function now to basically update the position of Bob. So we could do it just after the run. So we could say void update location, right? So we could say that the location dot add self a new vector, right? What would be the vector that we would use to update the location? Well, we could call that the velocity, right? Some speed or like some displacement or some movement, right? So I'm gonna say we don't have such vector yet, so we need to create it. So if we say something like add to the location the velocity, as we have done with theorem behaviors in the past, we will need to just provide a vector of velocity, right? And for now we could say that the velocity, just for now, it's gonna be a new vector of 1, 0, 0, right? Just one in x, right? So once we update the location, we should get this object to move. So we could, in our stack of functions that we create here, we could call our function update location, right? So we're making every frame the location to be updated, basically add to the location 1 unit in x. And you can see that what we have is that Bob is actually moving, right, to the right. And that's very straightforward. The problem with that is that I don't really want Bob to move every frame, right? What I want to do is just that Bob appears in the center of the screen, makes one step to the right, let's say moves so many units, and then it stops. That's it. Nothing more. So this is actually not what I want to do, right? And I want to just also record the information of what was the original location in which Bob was created. Bob, I'm calling the instance of this stick, right? So we could also say the following: vector3d original location. Oriloc will be our original location, and we're going to say that oriloc is _loc.copy. So we're going to make a copy of that same original location. So the one that we are updating constantly is location, but the original location is not updated. So we can actually do in the display function a line by saying, I'm going to copy that, I'm going to say a white line with a strength of 1 and line of from the location to the ori location. From the location to the original locations, right? So whatever movement we do, we are capturing with a line showing where it was created and what is my new updated position, right? So if we would show this now, we would see that we would get a line from wherever we were created, right, to the new position, right? And as I said, we don't want to just keep on moving. We want to just do this once. So how do we do that? If we move this function update location and we cut it and we place it in the constructor, we could make a little comment here and say stack of functions that get executed only once, right? Because the constructor works as the setup. This bit of code gets executed only once at the beginning of the class, and it doesn't repeat over and over again, right? So if we would check that now, we would see that the point is not being updated. It just moves a little bit. That's why we can see the difference between the red point and the point on this line, basically. But it doesn't happen. It doesn't happen every frame, right? So now we can actually use a velocity that is much larger to make something like a stick, right? So we have a point that was created here, and the first frame it moved 100 units to the right, and it stopped. That's it, right? So that's a very simple class, right? So, but what happens if we want to provide the information of the velocity in the constructor? So we don't use this velocity here, but we actually can provide that information from the outside when we actually create the class. We can say vector 3D underscore velocity and velocity equals underscore velocity, right? So that information now it's going to have to be provided whenever we create the class, like here. So we're going to say initial velocity and vector 3D initial velocity is a new vector 3D of 100, 0,0. Right? So we are providing an initial velocity for this entity to move to the right, but it could be in any direction, right? We could say maybe 100 units in Z as well, doesn't matter. Oops. Right, so in this case we're giving a, you can see if we put 100 units in Z as well, we can make that initial velocity go in a different direction. So for now 100 units to the right is fine. But what I want to do now is just not only update the location, but before that I'm going to call a function called update direction. Right? And the update direction function obviously doesn't exist yet. We will have to create it, and we're going to say void update direction. And basically the update direction is just a rotation of the velocity vector. So we're going to say velocity vector dot rotate z by angle 1 and float angle 1 equals radians of 30, right? Saying radians of 30 is like do the radian version of 30 degrees. This variable angle 1 is going to be the radian version of 30 degrees, right? So we're making pick the point, pick its velocity and rotate it in 30 degrees, right? And basically add that velocity to the location. That's what we're saying, right? So in this case we should get the same of what we had to the right before, but now we have 30 degrees to the right, right? So this is looking very promising. Like, well, you might not know where we're heading. But what we want to do is just that this class creates another one of itself, and that class will create another one of itself, and so forth, and this will happen recursively. So we can actually generate something like a branching structure, right? So this is where we're going with this. The only thing that we're missing now here is a function called spawn. So let's write that. And the function spawn is the main one that will actually create a new version of this same class. But the problem with this function is that we need an exit. If a class gets created and that class creates another class and that class creates another class, we will end up in an infinite loop, right? So we need to specify a number of iterations or generations, right? So we would say something like in the constructor integer, underscore generations, right? And we're going to create also a global variable in the class called generations. And then, as usual, generations equals underscore generations, right? So again, when we create the class, now we need to specify the number of generations, and we will say something like 4, just to start. It seems that we are using a space that shouldn't be there. It seems fine. Straightforward, but no errors, nothing fancy happening yet. So let's see what we need to make this spawning work. The spawning needs to say, first of all, this will only happen if generations is bigger than 0, right? We do not want to go forever. We just want to go certain number of generations, right? But basically right now we are only creating one bob. We don't have any kind of structure or any kind of array or collection that would allow us to create more than one entity of this class stick and allow to just call the function run for for all those elements. So we're going to create an array list first. Array list called all bobs, right? And all bobs is going to be a new array list, basically of all bobs. And when we create bob, we will say all bobs.add bob, right? Whenever we create an instance of the class, we will add it to this array list. And what we are doing here, instead of saying bob.run, we will need to change this for a for loop, right? So for integer I, right? If I'll try to do it the shorter way, right? In which if we specify a flag, I think something like stick. This is called flag, right? So if we specify this flag, let's see if this is working. Yeah, it seems fine. We could do a shorter version. If we do that, we can actually call a shorter version of this for loop. That would be for stick b in all bobs. b.run. Let's see if that works, and I'll explain it in a second. Yeah, it seems that it's working, right? So this version of the for loop, that I think that I appreciate the comment by Colonel Cardens from Belgium that he sent us some of the feedback on that. It's a very short way of making a loop through an array list. If you are familiar with Python, this is similar to a for each, but it's basically saying, knowing that the all bob array list contains only elements of the class stick, because we have specified this tag here, or this flag, we can say stick b, that's the name of the instance, belonging to all bobs, call the function b.run, right? So we're just saying call the function b.run for all the elements inside the all Bobs array list, right? It's the same thing of what we've been doing before, where we would just specify a long for loop saying for integer I smaller than 0, I smaller than all Bobs.size, I++, and then basically getting the element I of the list. This is doing that whole thing in an easier and shorter way, right? So again, it's going through all the elements in the all Bobs class and running the loop, right? So the only thing that we need to do now is in the spawn function inside stick, we need to create. Basically, this is the way we create a Bob. We basically create a vector of location, we create a vector of velocity, we create an instance of the class, and we add that class to the array list. So I'm going to copy that, and I'm going to put it into my spawn function here. So let's see what we have. We are saying vector 3D v equals da 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 da. Well, in our case, the v is going to be the location dot copy. Right, so we're going to change that for the location. In our case, the initial velocity is going to be a copy of the velocity dot copy. Right. So now we're going to call this guy new Bob. It's a new instance of the class stick, located in a copy version of the location with a copy version of the velocity and with generations -1. So whatever the generations were, this will be a generations -1. And again, this new Bob has been passed to the array list. So now we're in a good position to just check this. Let's see. New Bob. Cannot find anything called new Bob, so we're going to say stick new Bob is a new instance. So there we go. Oops. That should be fine. So you can see that what we have created is that we are passing the information from the first Bob, then the location where the first Bob ended becomes the starting point for the second one, and the velocity of the direction in which it was pointing, it became the velocity for the second one, right? So we keep on doing this as far as generations we have. So if we do more generations, let's say instead of 4 we could say 9, we can see that we're creating more of this, right? But what we are interested in now, it's like that's really cool, but we can actually we need to just basically branch, right? How do we branch? How do we create? In this case, we could say all this stuff twice. So I'm just gonna copy it, and I'm gonna say do it twice. But the problem is that each one of these Bobs, right, it's going to rotate for the same direction, right? It's going to rotate to the right, like in 30 degrees. So we need a way to specify that there are different types of Bobs. Some of them rotate to the right and some of them rotate to the left. So before doing that, I'm going to just do another thing here, and I'm going to say integer or string even. We could say string underscore type. And what this type is going to be used for, it's going to be a variable that would represent what kind of entity I am. The ones that rotate to the right or to the left or up or down or whatever. Right? So let's do a global variable called type. Right? And then type equals underscore type. As we have been doing before. Right, if we would try to run this, we will see that we will need to specify a type. So I'm going to say type A to start with. And again, when we create a new instance of Bob, we'll say create another A. Right? Right now, this type is not doing anything at all. Right? We need to activate that type in a certain way. So we could, in the update direction, we could say if type equals A, rotate to the right, right? If type is B, rotate to the left, right? So we're giving two cases in which A and B are potential cases, right? And they would rotate in opposite directions. The problem is that we're only creating type A right now. So now we can actually copy this stuff and create out of 1, 2. So I'm going to call this one B2, initial belt 2, B2, initial belt 2, and this guy would be at B. And we will call this new bob 2. Right? So we can see what we have. And you see that we quickly created something already, still 2D, where an initial direction A, we can actually get rid of this box now because we do have elements in the canvas, branches, one in minus 30 degrees and the other one in positive 30 degrees. And we can keep on doing that over and over again, right? And we get this kind of emergent branching pattern, right? So that's pretty good. But we can do much more with this, right? So I'm going to gray out this box. And what I'm going to do now is just, I'm going to say that this is only the case if type equals A, right? So I'm saying if I'm type A, make sure that these parentheses are fine, right? Make sure that you're kind of opening and closing. So type A will branch into 2, right? And we can copy this chunk here and say if I'm type B, maybe I don't want to branch. I just want to do 1. And the one that I will create will be of a type C, right? So we will have to specify a type C. And if I'm type C, maybe I want to create a type A, right? So every time we create a type A, we will create an A and a B. Every time we create a B, we will create a C, and every time we create a C, we'll create an A. So we have something that it's quite complex in the way it's kind of passing the information from one type to the next one, and it keeps looping and looping and looping, right? At the same time, we will need to specify if your type C, maybe rotate in an angle of 11 degrees, but maybe in X, not in Y. Sorry, in X, not in Z. Right? So let's check what we have so far. So you see that our L system starts getting a little bit of depth because we did only 11 degrees, right? And we don't have something symmetrical that looks so kind of silly to my taste, at least at that stage. So we're really starting to design a little bit more with this. If we really want to just take this forward into kind of all its potential, we would probably do, that's why I put angle 1 here, because we could actually be working with angle 1, angle 2, and angle 3. And then basically rotating X in Y and in Z based on the 3 angles. So I could say maybe 0. I'm going to start with 0 in everything and just specify a few values, right? So first I'm going to copy this structure for the 3 versions. So in every case we can specify the 3 angles. So I'm going to say if it's A, maybe I just want to rotate in Y, maybe, I don't know, something like 27 degrees. And maybe if it's B, I'm going to specify only 90 degrees, something a little bit kind of more orthogonal. But if it's C, I'm going to specify maybe minus 11 degrees, right? So you see that I start getting something, and I could start playing with the values of this to create an L system. But what is interesting is that we can actually increase the number of generations, right? So because we're seeing just 9 generations, what if we do maybe 14? So we can see that this L system is pretty much, it's curling on itself quite crazily, right? So maybe I just want to make this 7 degrees. And this looks nothing like a tree, but it's perhaps something slightly more interesting. You could definitely do a tree, right? So that those structures of a tree are kind of inside this system for sure. But I'm sure that you can find much nicer formations inside a system like this one, right? So I think that this is getting rather interesting. The question would be, well, can we connect some of those sliders, some of those user interface elements to control this pattern? Well, certainly, right? The problem is that right now, if you look at this, everything happens in the setup. We are creating one of these elements in the setup, and everything happens only once. So there's no way of really updating the information of this system interactively, right? Let me prove that with an example. I'm going to just go into File, Examples, and I'm going to bring an example from Control P5. That is one really good example. So Control P5 window, for instance, right? So in this case, the Control P5 window allows us to just open a secondary window that would control the color of our first window or any information, right? So I'm going to bring this library into our system. Again, these things, we have seen them in the user interface tutorial. So the only thing I want to just create here, it's a control window that will allow us to control the L system, right? So I'm going to do a new tab called Sliders or Controller. So I'm going to make a global variable called integer or float angle 1 equals 0. And I'm going to make a function void UE that will contain all the information from the user interface. So let's put something like initialize the control P5. The control window is a new instance of this window here, right? And then slider S01 equals control P5 dot add slider. In this case, it's going to be called angle 1. That goes from 0 to 90. That is located in 20, it's 100 units times 10. Right, and S01 belongs to the window control window. right? So if we call this function UE here, we should be calling all the information of that tab, right? So we have a secondary window that would have a slider, that is the angle, that we can use to control some of the angles in our script, right? So this is the example that we used. So the function, the variable angle1 could be controlling maybe in our stick class this angle, right? One of the values, I mean, you could make sliders for everything, right? But I'm just going to make a few to just prove a point. But right now you can see that it started with this angle in 0, and if we move this, nothing really happens, right? Like, because this happened only at the first frame, and there's no way of controlling that information unless we do something to change this system. What I'm going to do is just all this stuff that happens in the setup, I'm going to cut it and place it in the draw, right? But this will, what we'll actually produce if we do this is that we're basically creating more and more elements every frame. So for that, what I need to say is that every frame I will clear the ArrayList bobs by saying all bobs.clear. So every frame we start from scratch, and we create all those elements over and over and over again, right? In that way, we could change the angle, and they will update. You'll see that right now. I could start playing with the angles, and that angle, you can really start twisting this system up, right? So you have a lot of control over the aesthetics of the cell system, right? So let's make a few more of these sliders and see what are the kind of potential sliders that we can do here. So we can say slider 2, and slider 3, I'm going to be angle 2 and angle 3, slider 2, slider 3, and this will be displaced in 40 units. Right, so I'm going to make angle 2 and angle 3 here. Right, so we have 3 angles, the ones that we have put some information in. So we're going to say that angle 1 was 5, the second one was 90, and the third one was 11. Right? And we should get something similar to what we had. But there are a few other things that we can control as well. We could control the number of iterations, right? We could say slider of 4. And in this case, this could be called iterations. And I'm going to say from 0 to something like 30, not so much. Integers iterations equals 4. So it starts in 4. And this one we will put it somewhere in 80. So if we use this variable iterations here in the initial bob, we could specify how many iterations that we will create in the L system. You can see that we start with 4, very few, and as we can increase this slider and we will get more and more, right? It seems that we're missing one of these sliders here. Right, so we need to specify here 60. We have 2 sliders on top of each other, right? So you see that if we put 12, then you can put more. And this is the original, the base kind of angles that we're working with, but we could play with these angles. I'm going to leave one being 90 because it makes it look really unfamiliar in a way, like that something quite organic could just have like 90-degree angles as well, and maybe play with the other ones. You can put negative values if you want and start creating all sorts of formation here. And again, play with to understand it, play with the number of iterations. You can produce something quite complex, right? So yeah, this is some of the control that you can inbuild. Like you can put sliders for all the variables of the angles here. You can make the variables go from -90 to 90 instead of just 0 to 90 or even more, like 180 or whatever. And you can also control the size of the sticks, right? You would do that by once you update the velocity, like here, you could say something like velocity dot normalize and velocity dot scale self by some value, like 100, right? Oh, you can basically do this in the just by cutting this stuff. Let's put it inside these conditionals of types. So maybe branches A, they're gonna have a length of 100, right? Branches B will have a length of maybe just 20, and maybe branches C will have a length of maybe 40, right? So you're changing the size of the length of the velocity, which reflects on the size of how much you move as a point based on these values here. So each type of branch will have a different length, and you can put sliders on these values as well, right? So you can interactively play with all the functions. You can see that we have some of these branches that are quite small and some of them that are larger. So again, you can play here with the number of iterations to create enough population, and then just play. In this case, I have negative values as well. So again, the possibilities quite endless. And I think that I wanted to just make a video of this system because I think that this system produced quite interesting formations. And it's pretty straightforward. You're just basically working with one class that replicates itself over and over again, right? So if you do anything cool with this, just please send it to me. We'll be glad to see your developments. And I hope that you guys like this tutorial. See you guys soon.